So for the L sub r, we're done with solving for the L sub p, no? Because we are now in letter B. Then we'll try to find the value of L sub p and L sub r, no? And we're done with L sub p. For the L sub r, the equation is, the formula is this one, no? This long formula. First is try to find the value of r sub ts, no? That is r sub ts squared is equal to square root of the moment of inertia times the CW. This is the warping constant. This can be found in the table, and the elastic section modulus. So for the steel, W14 by 68, no? The warping constant can be found in the table of properties, table 1-1 by the AISC manual. So W14 by 68, from here, no, wala kay value. So meaning naa siya sa sunod nga table, this one. This one is W14 by 68. So W14 by 68, your warping constant is 5,380. And your modulus of elasticity, R sub y, is 121 inches to the fourth, divided by S sub x can also be found in the table, that is 103 divided by 103. So the value for your R sub t, square root of this one, is 2.791 inches. R sub ts can also be found in the dimension properties. Alright. This can also be found, no? Napod siya actually sa table, no? Naa siya diri sa kani, which is equal to 2.8, no? For using the formula, the answer is 2.799, which is almost approximately equal to 2.8, no? Then solve for the h sub o, or h sub 0 is equal to d minus thickness of the flange, no? The depth, this is the depth d, which is equal to 14 minus thickness of the flange, can be found in the table properties, no? Table 1-1, which is equal to 0.72. The value for your h sub o is equal to 13.28 inches. H sub o can also be found in the dimension properties table. So actually, the values for this L sub r, most of the value for these specific parameters can be found in the table dimensions and properties tables, no? H sub o can also be found in the table, which is given as 13.3 inches, which is almost equal to the computed 13.28 inches, no? Kung atong tanawon sa table, H sub o is equal to 13.3, no? Then for doubly symmetric eye shape, the value of C is equal to 1.0. So now this is introduced earlier, the value of C. So substituting the values for the value of L sub r, 1.95 times your computed R sub ts, or from the table, times E over 0.7 times the yield strength, the square root of the J. J is the torsional inertia, or this is the factor or the parameter caused by torsion, or J in the strength of materials is your polar moment of inertia. This can also be found in the table, which is equal to 3.014 W14 by 68 times C. over S sub x. This is the elastic section modulus times h sub o plus square root of jc over S of x h sub o squared plus 6.76 times the quantity 0.7 fy over e squared. Now, so to solve this term here, j is 3.01, which is from table, no? 3.01, and value of c is 1.0, s of x, or the elastic section modulus is 103 times h sub o 13.28. This is equal to 0.002201. Substituting this value to the formula, no? Then you can get that the L sub r, or the limiting length for the elastic region, is 29.28 feet. Comparing this value to the value of the L sub b given. L sub b given is 20 feet, and the L sub p is 8.692 feet, meaning this L sub b in the letter B is in the inelastic region, as you remember in the figure. This is between, no, the value of the L sub b, or the unbraced length, is within this inelastic lateral torsional buckling, no, because 20 feet man to, then LP is equal to 8 point something, while L sub R is equal to 29.28. So, naa siya sa between, no? Since this L, or the unbraced length, is within the range, no? Within this L sub P to L sub R, use the value of the nominal moment equal to, or the formula, no, equal to this, C sub B times the quantity M sub P, or the plastic moment, minus the quantity M sub P minus 0.7 Fy S sub x, times this ratio L sub B minus L sub P over L sub R minus L sub P, which is equal to less than or equal to the plastic moment, no? Because this M sub N, nominal moment, below siya sa plastic moment, no? Because this is still in the inelastic region, no? Then C sub B is given, which is equal to 1.0. The